Hey YouTube, it's JP Dillon. Welcome to part 2 of the early 70s Sony STR-7065. In the last video, the machine we powered up, found out that it had lots of dirty switches, noisy controls, no FM stereo, and a really nasty phono hum. So unfortunately we have to try to tear down the back panel to get to the phono jacks, because I have a fair idea that the coupling between the ground sheath on the RCA and the chassis has lost its grip. But we also need to take a look at the regulated power supply and make sure that's not an issue either. But first, let's do the obvious. Let's check the connections, and let's get to it. Okay, so to get at the back panel, I'm hoping it's not going to be too scary. You do have to take off the bottom, and then there are screws on the side that hold it to the chassis. So I'm going to remove those. And we're going to see if we can fold down the panel enough to get to the phono input jacks. And if it's the type of jacks that I think it is, I'll show you what goes wrong, which is turning out to be more common nowadays. But let's see if I can actually get this down well enough to see it. Looks like I'm going to have to undo some more wiring and stuff here. Like that ground strap there needs to be undone. And let's see, I've got some okay slack here. These here are a little firm. Okay, so yeah, basically, let me move this up again. And it's not going to cooperate, of course. We're going to introduce some Shaco-Vision here. Let me undo this ground strap really quick, and then we'll see if we can fold it down a little more. Alright. Should give us a little more freedom. It does. Trying to see what else I'm being hung up on. Oh, look, another ground strap. Which is weird because it's to the same place. Okay. So be it. Let me take this one loose. Alright. Come on. Let's see. And then there's the antenna leads. They make this like really, really tight back here. I have to try to get loose everything that I can in order to fold this down enough to get to the jacks. And let's see, there's this blue lead here for the AM antenna. So this is a reason why I don't like messing with these Sonys all that much, just because they do have their build issues. And it's all about the degree of freedom. Let's see, let me loosen that terminal strip here on this side, and we'll see if we can get the rest of this here. There's a clamp that goes with that. Alright. And then looks like I have to loosen the voltage selector switch. All of these things have been constraints in getting this back panel down. It's not easy. Okay. Oh, that's just for the cover. Alright, don't have to take that all the way out, that's good. Now, there we go. Alright, Now I can show you all what's going on with this thing. Alright, so here you're looking at the set of input jacks. And we're going to pay close attention to the phono jacks, which are the ones at the very left of these guys over here. So here's the failure. Let's see if I can get this up and still. There we go. All right. So here's the failure. You see that these two are pressed together. And you have this outer ring here, which is your ground. And we can see that that grounds to the bus bar right here. But the actual RCA ground is on the inner one. And what happens is you get oxide that builds up between these two because they're just press fit, and you get a loss of conductivity to the ground. And so as a result of that, we get your nasty 60 cycle hum that shows up. You see it more in the phono section than you do the other ones. Like this is the auxiliary. We didn't see any nasty hum on auxiliary, but it does, you know, I should probably do these two. But you have your nice big fat bus bar down here, which everything is soldered to. And I can pull up on the lugs here and it doesn't move, which tells me it's still attached to the bus bar. But yeah. So let me get the capacitor wizard, which is really good for checking this, and you can see what the difference is. Okay, so I'm going to place one of the terminals of the capacitor wizard on the ground bus bar. And just to do a reference, we're going to touch the other one here, and we get 0 ohms. Now if I touch the ring here, which is soldered to that bus bar, I get 0 ohms. But if I come in here and I touch the ring here, I get 2 ohms ESR. And that's repeatable. Let me show you what it looks like on camera when I touch it. Alright, let's see if I can turn this a little bit better. The angle of the lights is not helping. Just adjust our exposure here a little bit. There we go. Alright, so first we're going to do the quality test. Now if we go from bus bar to bus bar, let me zero this out. I just changed the batteries in it, so I need to adjust the zero again. Alright, so let's go from the bus bar to another spot on the bus bar. We got our 0 ohms. Let's go from the bus bar to the outer ring. We get our 0 ohms. Let's go from the bus bar to the inner ring. Get a good grip on there. You can see it's not very good. If I push on it, I get a little bit more. But otherwise, if I just touch it, that's the outer ring. Come on now. If I just touch it, it's not very good. Let's look at the other one, which is the right channel. Shit. Right channel doesn't register until I really push on it. If I really push on it, you see it's better. But anyways, those need to be resoldered, soldered together, and that makes it so that there is a clean connection between the two. So let me show you how I do that. So basically what we're going to do is scrape the surfaces on the inner and outer ring a little bit here. If you have a more available space, you can usually take a Dremel tool with a wire brush or something like that and get on in there. But I'm just trying to scrape the oxide away here, because what we're going to do is solder the outer ring and the inner ring together. We're just going to use a really hot soldering gun to do it. Alright, so I've got my soldering gun, which we're going to heat up. Gotta wait for things to get hot. Tin the end a little bit. And we're just going to lay this down on the ring here. Get it good grip, get it toasty. And we're going to get the solder to flow between the 2 points. Try to get it to flow well between the 2 points. There we go. Alright, that's one. And let me get this out of the way down here so I don't scorch the wiring insulation. And then we'll do the other one. So this problem is showing up a lot now with machines that come in. So I'm starting to see more and more bear with me a minute, I'm reshaping my tip so it works a little better. And it'll always be the same complaint, is that on the phono input it'll be like super buzzy. And they will have tried new cables, and they will have tried all sorts of things to try to make it work, and it just doesn't. See that one? I don't know if my tip is contacting. I can't really see it from this vantage. Looks like it is. Here we go. Alright, so that's basically, I just want to make sure that there's an absolute connection there. So let's go ahead and check our work real quick. Alright, so we're going to go between the bus bar and the outer ring, which looks pretty nice, and the inner ring, absolutely solid. There's still a little tiny bit of difference because of the capacitance in the bus bar. Oh, there we go, nice firm connection there. And then nice firm connection there. So if we look at some of the other ones here that are still here, not quite as close. That one's pretty good. Let's see, so that one up here, that one could use some help. So yeah, to save time, I'm just going to do the rest of these, solder up the rest of these things, and then we'll get to the, put this back together and then get to the regulated power supply and the tuner. Alright, so here we are back together. And previously, when we had it on phono, we had this scary amount of hum in the signal. Let me pop this off the holder here. And ignore the channel imbalance because we still have to deal with that. But look, clean signal, no hum on top of it. Before, we had the 60 writing on top of this and it was like super shaky. Curve looks good and all that. We still have a channel disparity between the two. Just really quick here, let's figure out if that's a power amp for preamp thing. That looks like a preamp thing because power amp looks beautiful. Alright, well that's probably more capacitors and things like that. But anyways, we got the phono problem resolved. Let's take a look at the problem with the FM stereo that's not working. Okay, the first thing I noticed right away is that the sensitivity of this tuner is junk. We're not getting much of anything going in here. I think that's because the RF lead broke loose there. Let's fix that first. Okay, so soldered up, that's, that's fixed. And that's what we had, was a busted RF connection. And that was probably my fault. Alright, so we have no stereo separation, kind of like that Sansui. Now that twitching you see is the not the power supply. It's switching between stereo and mono. Because if I turn the pilot off, you get the transient. If I turn it on, you get the transient. If I mess with the signal strength, it switches between stereo and mono. So the switching circuit inside the IC is working. It is not demodulating. And let's see, I think this uses the infamous CX0431. Yeah, there it is back there. So accessible. Okay, so let's see if we can get to it from the back side. And there's the back side of the IC. So what we have to hope for is that it's a failed component like a capacitor or something like that, because if it's the IC itself, there's really nothing I can do, because these ICs haven't been available for some time, and they are absolutely Sony specific. So let me print out the schematic real quick and we'll do some voltage checks. Alright, so you see what they have here is you have a MOSFET or an FET, which is supposed to be the 19 kilohertz amplifier. And I think we're doing okay there, because if we go back to our scope and we take a look at it, we see that when I turn the pilot signal off, there is a shift change. It's shifting between stereo and mono mode. So that it's probably recognizing that there is a signal there. So then what we have to do is check various voltages. This looks like a VCO adjustment, this 301 here, but they don't tell you, other than what the voltage is supposed to be, 1.2 volts, what frequency it's supposed to run at. I love it when people call like 2 hours before I'm open. Anyways, let me get that. Alright, so I think we're just going to go up the line here and see what we got going on. Like pin 1 supposed to be 13, we got 12.8. Pin 2, 17, we got 1676. Pin 3, we're supposed to have our 1.2 volts, that's our input pin there. It's a little high. Or no, 1.2 is pin 10. Pin 3, I'm not sure, it doesn't list a voltage there. Let's see, pin 4, we're supposed to have like 17 volts there. Let's try not to blow it up. Pin 5, another 17 volts. Someone's been soldering on this IC too. Pin 6, 5 volts. That's pretty close. Pin 7. Let's see, where's pin 7? I don't see a pin 7 listed. .8 volts on pin 7. Pin 8, 3.8 volts. That's pretty close. 9, don't see a 9 there. 10 is supposed to be our 1.2 volts. Pretty damn close. And don't see, let's see, 11 supposed to be 11 volts. Yep, 12, 11 volts. 13, don't see here. Well, the next thing I see is 16, 17. Okay. I just lose count? Yes, I did. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 looks low. What's going on there? Let's double check that. Yeah, that ain't right. All right. 8 pin, 9, 10, 11, 12, 13, 14, 15, 16. 16 is supposed to have 17.5 volts on it. Let's see. That would tend to suggest that the lamp here is open, or the resistor feeding the lamp is open. All right, so let's see. 16 has low voltage, as I recall. Only 2.9 volts there is supposed to be line voltage. 18 supposed to have 2 volts on it, and it doesn't. And 19, I don't even see a 19 on here, but that's your 17 volts. Okay, so we got something to look at here. I don't know. Some of these chips require that this lamp be functional in order to switch on. So we can try replacing this lamp and see if that restores the 16 volts there. 15, where did I see 15? No, 17 was low and 16 was low. Let's double check that. Yeah, 17 is nothing, 16 is 2.9. So I'm getting some voltage here. So maybe this 270 ohm resistor is open. Because this would not power this. I could see this pulling down the low side of the lamp, but it looks like this is fed from a power line here. So we need to check and see if that lamp is open. If so, replace it. And then 17, I guess 17 is ground. So there shouldn't be voltage there. Okay, so, but otherwise, all the voltages on this are happy and it should function. So we have to take a look at pin 16 here, because this may be one of those weird scenarios where if the lamp's dead or this voltage through the lamp is not supplied, this doesn't demodulate. I have seen that. So what I need to do is come up here to the stereo lamp and see if we have voltage on the high side of it, and then the high side of that 270 ohm resistor. So it's really tricky to see here because of the density of components. But if you'll keep an eye on this area here, these two blue wires are the PL905 stereo lamp. And then R306, which would be really close by, that's supposed to be our 270 ohm resistor. I'm going to turn this off real quick and just ohm out this lamp and see if we have anything here. And it's hard to tell because there's still a voltage on it. You see how much voltage is still on it. There shouldn't be a voltage on it. Actually, there isn't. There's like 9 milliamps. Okay, so it can be assumed that that lamp is open. So what I want to do briefly is just clip across an 8 volt 50 milliampere lamp and see if it lights up and see if we get our stereo demodulation. Okay, so I'm just going to take some clip leads and just go right in there. Now we're going to see if the lamp lights, and it does. All right. Be nice if it would focus on that. Okay, and wouldn't you know it, let me pull this off the camera mount here. We now have our stereo demodulation. So this multiplex decoder IC requires that that lamp be in circuit and functional in order for it to do its thing. So if I remove and add the pilot signal again, take it away, it's mono. Add it in, it's stereo. Let's do a brief adjustment of our separation here. If it'll let me do that. There we go. Null it out a little bit. Okay. So that takes care of that fault. It's just this silly lamp. And if I take it out of circuit, it goes back to being mono. And it doesn't like being mono because it keeps doing this twitch thing when it's switching between. Alright, so lamp's going to go in. Alright, so here's our leads that I've stripped and tinned. I'll put some shrink tubing on these. Zoom out a little more so you can see what I'm doing. And then I'm going to take my little lamp that I have soldered up and stuff. If I can find where I set it down. There we go. Alright, so I'm going to attempt to attach one lead at a time here. It's hard to do it in free-floating space. Alright, let's give a little tug on that. And let's do the second one. Toughest part is getting this stuff to cooperate. Could use a little more solder on the tip. Yeah, I figured that wasn't connected. Alright, that's not cooperating. I need to get a better grip on where it is and what it's doing. Bear with me a second. Alright, much better. Nice little tug on that, doesn't come loose. Let's get the heat shrink up on it. And let me get my hot air gun. Alright, and now I'm just going to insert it down into this grommet here where it was. And then I'm going to put a little dab of glue on it just so that it won't float away. There we are. Okay. So that's that. Now we power up. Got our little stereo light lit up there, and we have our stereo separation, which is really good. Let's do a minor touch-up on the tuner. So you're going to want to remove that shielded cover, which requires that you unsolder the ground strap up here that we did earlier. This is your RF trimmer set. And then we have some fine trimmers down here and our IF transformer output. So what I'm going to do is we're going to, I can't remember if this one's the FM or if this one's the FM IF output. But we're going to scope it there and we're going to see what our 10.7 looks like coming out of there. And we're going to peak these guys for the 10.7. That's the best way to work it. Well, it looks like it was the middle one that was just the FM out, but as we can see here, I scraped away the brown glue, but the brown glue has eaten the wire that came out of here. Not good. That explains why our sensitivity was poor and got worse with the disconnection there. But if I stick my probe in there, we have a 10.7. That's twitchy. I don't know what's going on there. That's me moving it around. Okay, so we can do the front end alignment at least, and then we have to reattach that wire, which that sucks, but yeah, gotta do it. Anyways, okay, so this is gonna be fun. I'm zoomed in on the scope because I don't have enough room to do both at the same time. So we're going to look at our RF, and I'm going to adjust the antenna trimmers here, starting from the one on the right hand side. We're just going to peak it there. Middle one. And it's really hard to hold my hand still, so I apologize for that. We're going to peak that one. And then the third one, which is already pretty much peaked. All right. So that's coming out of the tuner. That's good. And it goes right into an FM chip. There's nothing more than tuned ceramic filters. So you're not really going to see any more improvement or tweaks available. You just basically tune what's coming out of there, and assuming that the IF chip, which is the 0451, I think, this guy here, this is your FM, assuming he's cool, it's going to work all right. But we need to reattach this, which sucks because it's not very accessible. But let's see if we can figure out how to do that. And of course, the only visible access I have to the back side of that board is through this hole. And I really don't want to destring the tuner if I don't have to, but I need to find a way to get that piece of coax reattached. Otherwise, our FM performance is going to be diddly. So let's take a look at this. Alright, so sadly, the only way to deal with this without yanking the tuner out, I'm going to try a little bit of a desperation measure here. And what we're going to do is move this out of the way. And I'm going to take a piece of cut-off lead, the thinnest one that I have, and we're going to heat it so that it gets super hot, and we're going to punch through the solder and then try to trickle some more solder down the lead and hope that it attaches itself to the board, because I think that's the only way we're going to get our wire reattached without taking the whole tuner out. So I'm going to heat this up until it starts to sink in. Applying light pressure. I think I need a higher concentration of heat. Let's pre-tin this a little bit better. That way the heat will travel down it a little bit nicer for me. I'm applying too much pressure, I guess. There, nope, that didn't work. It gave out. All right, that one's been compromised. I don't want to reuse that one. And it may be that the brown glue in there has become a preventer of transmission of heat. Nope, didn't quite take. Might have to use more heat. It also doesn't help that the hemostats that are holding onto this act as a heatsink, and they may be taking away the ability to punch through. I don't think this one made it either. Nope. I think I'm taking away too much heat from here. So I need to find either a longer lead or a lesser means of contact, or I need to grip this as lightly as possible. The other thing would be to find another attachment point on the board which leads to that spot and attach it there, which I think will be my next step if I can't get this out or in the hole. So we're going to try one last time. Longer lead. And I'm going to set it as far back as I can. Yeah, I don't think this is working. It just never gets beyond the solder wall. All right, so let's take a look at the schematic diagram again, and let's see where we could possibly attach that piece of coax to that would be meaningful. So it looks like the bottom of C110 would be where we'd attach it to. All right, so we'll have to mess with this in a little bit. The low side of the capacitor is right there, the green thing. And so what I did was scrape away so that there was bare lead on the capacitor. I tinned a lead, put it down in there, soldered to it, and then soldered the coax to the lead. And it looks janky, but the capacitor survived. It's very secure, and I don't have to worry about trying to pull the tuner out to string it, pull that little board off, and all that mess. So look for that. The brown glue had eaten through here. I checked this one's still alive, but I am definitely gonna scrape away a little bit here. We just move the tuner back. Like this should definitely get scraped away, because obvious the glue will eat through all this mess. It's a terrible thing. This one was corroded though, yet the other ones weren't baked yet, so I'm going to scrape that off a little more and then we'll recheck the tuner. Alright, so something's definitely right now, because before I never had a really high register of tuner signal. So that definitely might have been a reason why, if he was complaining about poor reception. So that's something to look at. I scraped away the remainder of the brown glue around the others, but check and make sure that the glue hasn't eaten through your coax to the RF section. Bad juju. So everything's cool. We still got our stereo beacon and our stereo separation. It's looking pretty good. God, that input selector switch, man. I just left that alone for a little while, and it's kind of crummy again. Of course, that's... yeah, it's dirty switch on my signal generator, but still, look at that. I can touch it and it gets yucky. I think it's been sitting for like maybe a couple days. I think that's the only one though. Yeah, so let's get the strong stuff and let's hose it. Yeah, forget this, we got the thicker D5P, which will probably work a little bit better in this scenario. Yeah, so remember this fun mess? Alright, gotta do this again. And we're gonna pump a bunch of the heavy duty stuff up in here. Just basically flood this switch. Then I'll do our wafers. I don't care if it's messy. It's just got to work. And then we'll just work it a bunch. We also need to check for bad solders on these switches too, because that could be an issue. Yeah, it's always something. Let's check the solder side. So the solder side definitely looks crappy. You see the darkened areas around where the leads protrude through the solder? That's oxidation. You can see that somebody already soldered a couple things down there, so that's definitely a telltale sign here. So let me pan over to the scope, and then let's turn this on. And if I turn the input selector, we see that the touchiness has gone away at least. But if I wrap on the connections, see how the right channel trips out? See how it's going twitch, twitch, twitch there? And if I hold the selector switch, it doesn't change. So definitely some bad solder there. Let's turn this off real quick. And then we'll come back over here and focus on the board. If the camera will cooperate. Come on, camera. Let's not do that. All right, hopefully it will maintain focus over here to your right. We'll see, or I'll just do this. And I'm definitely gonna touch up these connections here because that would be annoying to say the least. And it would probably change with thermal. It heats up or it cools down, and then all of a sudden the machine behaves differently. So this switch down here has already been resoldered by somebody. That was not me. I think it was the last guy that I got it from. I mean, he did okay work from the standpoint of replacing the diff amps and stuff. I guess he just ran into all these additional problems and didn't want to tackle it. But I am of a different mindset, I guess. I kind of like these machines. I have an affinity for them. Even the ones I don't like, it's like, why throw it away? Fix it. I was brought up to basically fix it until it couldn't be fixed anymore, and then use its parts for something that can be. We focus too much on new technology and making everything obsolete. The state-run consumer affairs board always wants to check and see that I'm recycling properly. It's like, well, I think the operation we have here is the definition of recycling. We're keeping stuff out of the landfill. Let's do this guy here too. He's kind of bugging me. A lot of these connections aren't great. And then these discolored ones over here have a nice ring around the lead, indicative of soon-to-be failure. Not to mention the discolored solder is a good indicator that it's gotten a little hot. Alright, so let's see if we wail on it now. Is it going to behave better? Yeah, see? No more twitchy. No more twitchy right channel. So when you see the little discoloration where the leads come out and it's darker, that's oxidation. And that means the solder in there is bad. You want to definitely reflow that with fresh solder. So we took care of that issue, which is good. The next thing of note is the tiny discrepancy between the left and the right channels. And let me come over here and zoom in on this thing. And if we overlay the channels on top of each other, Do that here real quick. There's our right channel, and there's our left channel, which you can see. And just make sure that this is right on top of each other. I think it is. Right channel, left channel. Left channel is definitely smaller. Let's frequency sweep it and see if that changes based on frequency. You can hear it singing in the output transistors. So it has this tiniest little bit of change, but really it's not significant. So that tends to suggest that it's not a capacitor problem, since capacitors shape frequency response. Now it could be a gain problem, but I think earlier we determined by going directly into the amp input that it was strictly in the preamp. So the next thing we want to do is move our scope to the preamp section. We're going to check it at the volume control to make sure that it's not the volume control, and then we'll check it at the balance control and then the input to the preamp. Because frequency response wise, we don't really have a change in amplitude too much until we get past about maybe 15K, which would be about right. So I don't really think it's a capacitor issue, because if it was, we would definitely see a shift change in the frequency response. So let's move over to the preamp section and see if there's any difference. Okay, so right now this is looking at the output of the volume control. And if we come over here and we take a look at our scope again, maybe it'll try to do something better about focusing. We see that there's no difference now between the left and the right. Those are the both channels imposed on each other. So no difference. So at the volume control, we are cool. Let's take a look at the output of the balance control. Okay, so now I'm switched over to the balance control. And one thing I see is that there is, let me turn this off, a very slight discrepancy. You can see the line's a little bit blurred. So if we start out with one, we start out with the other, it's a little bit blurred, not much, and that changes ever so slightly. So now that's probably not enough to show up as a 1 or 2 dB difference. So yeah, the controls may be a little bit lossy, but I don't think that's it. I'm more inclined to believe that there's something going on in one of these preamp ICs. I believe that's one down there, and then there should be another tone amp somewhere buried in here, although it could be discrete. So the thing of it would be is come in over here with those wire wraps there. That's where the preamp comes in, and we can go to our mode switch right there where it's stereo left and right. And first let's come back out to our speaker output and reduce the gain on the scope here. Bear with me a second. And you can see that there's a tremendous difference there, especially at lower volumes. You see how it's close, and then as you turn the volume up, it gets further apart. Let's reduce our input signal. That volume control is crummy again. But look at that. Non-linearity of the volume control. Now if I adjust the balance, which is also touchy, man, these pots are just yucky. We still have a little bit of discrepancy there. And it's throughout the range of the volume control. Oh, and then it gets really bad again. and then you have to center the control again. At maximum volume, with the balance control centered, we still got a little bit of a discrepancy there. But given the fact that the discrepancy changes throughout the volume control range, it makes me wonder if the elements of the volume control are not quite what they used to be. Since the right tends to be stronger than the left. And these controls, just yucky. Let me hit these things with some fader lube. So based on the volume control being a possibility, I want to measure the output of the control in relationship to ground and see if we have equal loading to the preamp. So we're going to start with the right channel, which was the higher of the two. And so at volume minimum, you've got 1.5 ohms off ground. And then we kind of jump really fast here to about 1K. Well, let's go all the way up here. So we're at 600K at maximum. We're at 600K at maximum. All right, so 612, 604. That's pretty damn close. And if we go to the halfway point just past the loudness tap, we got 56, and we got 58, 59, 60, pretty damn close. So I'm not really, I don't think that's it. I don't think it's the volume control. Let's take a look at the output of the balance control. We got 600 there, and we should have 600 there. Okay, so the problem that we're experiencing has nothing to do with the volume or the balance control. It's entirely after that. So that's a good thing to know because sometimes you can get issues with the wafers. If we go to the top side here, yeah, there's our 600K. So this volume control is fine. If you saw a difference in the resistance between the high side to ground, like at the volume control and at the top, then you would wonder, tracking wise, is the volume control at fault here? And it could be, but not here. So basically what we're going to do now is we're going to trace where it enters the preamp, and we're going to figure out where the signal discrepancy is. And I'm pretty much guessing it's going to be one of these preamp ICs, and we're going to check the caps and stuff around it. But that's for another video. Yes, we're going to come to the conclusion of part 2, and in part 3 we'll do some more serious signal troubleshooting with the preamp, try to solve the gain discrepancy there. And once we get done with that mess, then we'll worry about replacing the lamps and detailing it, making it look all pretty. But for now, I hope you guys enjoyed part 2, and more stuff to come.